Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dr. Jr., your math teacher, your math tutor, and an instructor of mathematics at the University of Liberia. In my today's lecture, I will be discussing differential equation, and particularly I'll be looking at eliminating arbitrary constants to obtain the differential equation. So we solved a lot of problems in previous videos, so you can check them up. We want to solve the 10th problem under eliminating arbitrary constants. So the problem says y equals to c1 e raised to the power minus 2x plus c2 e raised to the power minus 3x. Now, to do this now, what we need to do, we need to first, please don't always forget, determine how many constants first. Now, since we have two constants, it means we must have a kind of second order differential equation. That is, we must differentiate twice. So we differentiate the first time y prime equals to, now let's differentiate this one. So remember, we told you in our previous video, if y is equals to e raised to the power ax, it means y prime now is equal to a e raised to the power ax. That is, you rewrite e raised to the power ax and you differentiate the power. That gives you a. So this one now becomes c1 e raised to the power minus 2x times the derivative of minus 2x, which is just minus 2, plus c2 e raised to the power minus 3x times the derivative of minus 3x, which is just minus 3. So if we simplify, we have minus 2c1 e raised to the power minus 2x minus 3c2 e raised to the power minus 3x. So there's equation number 1. So from equation 1, we get equation 2. We have y prime prime equals minus 2c1 e raised to the power minus 2x. Now, remember we're differentiating e raised to the power minus 2x. So we rewrite it, and then we differentiate the power, which is minus 2 minus 3c2 e raised to the power minus 3x times the derivative of the power, which is just minus 3. So y prime prime equals 2 times 2 is 4. And then c1 e raised to the power minus 2x, 2 times 3, or 3 times 3 is 9, positive 9, c2 e raised to the power minus 3x. Now this is equation number 2. So we have these two equations. We need to find the values of c1 and c2, so we can write the two equations. Y prime equals to minus 2 c1 e raised to the power minus 2x minus 3 c2 e raised to the power minus 3x. The second one, y prime prime is equals to 4c1 e raised to the power minus 2x plus 9c2 e raised to the power minus 3x. Then we can apply a system of equation. So we want to eliminate one of the variables, one of the constant c1 or c2. So to do that, if we make this constant to be 2, it means, if we make this to be 4, it means c1 and c1 can go out. So we say let's multiply this whole expression by 2. So 2 times this is 2y prime, or let me put it on the side. So we have 2y prime, and then 2 times this is minus 4 c1 e raised to the power minus 2x. 2 times 3 is 6 c2 e raised to the power minus 3x. And then we rewrite the second equation. You have y prime prime is equal to 4c1 e raised to the power minus 2x plus 9 c2 e raised to the power minus 3x. Then we subtract. So this one can carry this one out. 2y prime plus y prime prime is just 2y prime plus y prime prime. Then the signs here are different. We subtract. The biggest number carry the sign. The biggest number is positive 9. So the answer would be positive 3 C2 e raised to the power minus 3x. But what have we just observed? We have just observed that we now have only C2 within the problem. So that is, if we divide this out by 3 e raised to the power minus 3x and divide this out by 3 e raised to the power minus 3x, 3 can cancel 3. This one can cancel this. So you will have a kind of C2 to be equal to 2y prime plus y prime prime all over 3 e raised to the power minus 3x. So we have solved for C2. Now we can take out of the equations now to solve for C1. So we take the first or the second equation. Let's take the second equation. You can even take the first, it will give you the same thing. So we take the second equation. We have y prime prime, and I'm not taking the second because I multiply this by 2 first. No, I can even take the first. So y prime prime equals to 4 c1 e raised to the power minus 2x plus 9 c2 e raised to the power minus 3x. What do I know? I know c2 to be equal to that expression. So I will have y prime prime equals to 4 c1 e raised to the power minus 2x plus 9 c2 now is 2y prime plus y prime prime all over 3 e raised to the power minus 3x times e raised to the power minus 3x. So this and this will cancel. And I'm left with y prime prime. Now, so I want to send this term across the equal sign so that c1 alone can remain. So it's like 3 here, 1 times 3 into this 3 times. So I can say 3 times 2, 3 times this, right? So it's 3 times 2, 6 y prime. And then 3 times y prime prime is minus 3 y prime prime. So the two of them have negative signs because I send them across the equal sign. And then it's equal to 4 c1 e raised to the power minus 2x. So I can divide this out by 4 c1 e raised to the power. Let's say I can divide this out by just 4 e raised to the power minus 2x. And then I divide this out by 4 e raised to the power minus 2x. Therefore, c1 will be equal to y prime prime. Now, y prime prime minus 3 y prime prime will give us negative 2 y prime prime minus 6 y prime all over 4 e raised to the power minus 2x. So this is the second equation. So what I need to do now is I need to be able to replace C1 and C2 within the original equation. So I have C1 and C2. So I replace it now within the original equation. So I got y equals C1. I know C1 is minus 2y prime prime minus 6y prime divided by 4 e raised to the power minus 2x. All multiplied by e raised to the power minus 2x. So this and this will cancel. Plus C2, 2y prime plus y prime prime all over 3 e raised to the power minus 3x times e raised to the power minus 3x. So this and this can cancel. So I'm left with y equals, now this is just minus 2y prime all over 4 minus 6y prime all over 4 plus 2y prime over 3 plus y prime over 3. So y equals, so the terms with prime, I can group them. So it's minus 2y prime plus y prime 4 and 3. And then these two. So I have positive 2y prime over 3 minus, so I can reduce 4 and 6. 2 into 4 2 times, and then 2 into 6 3 times, so it's 3y prime. So if I find my LCD for this first one, I have 12. 4 into 12 3 times, 2 6 y prime. 3 into 12 4 times y prime is 4 y prime. Okay, so the first one, this is okay, so y prime. And then I have plus LCD again is 6. 3 into 6 2 times 2 is 4 y prime. 2 into 6 3 times 3 is 9 y prime. So I can simplify the numerator. So this will give me negative 2 y prime because the signs are different. I subtract all over 12 plus the signs are different. I subtract 4 from 9. I'm left with negative 5 y prime all over 6. So it's like 6 here, 2 here, 1 times 2 into 12 6 times. So this is y equals to minus y prime minus 5 y prime. Since the denominators are the same, I can just take one of them divided by 6. So I can cross multiply. So if I cross multiply, 6 times y is 6y equals to negative y prime minus 5y prime. So I send this one across, is positive y prime plus 5y prime plus 6y all equals to 0. So this is the differential equation given the functional relation within the problem. So thanks ever so much for watching. See you in our next video.